All right, go live. All right, it's live. All right, go live.
Yes, okay.
Okay.
Here we are.
All right, it's live.
Awesome. Yes, okay. Here we are. Success.
All right, here we go. So, hello, Angelica, can you hear me okay? Are we live? Are we broadcasting to people?
We've overcome the many technical difficulties that we were inevitably going to encounter.
I love it. I love it.
But we are here.
It wouldn't be a...
Yeah, it wouldn't be a live stream unless we couldn't go live for at least 1 minute now over time. Awesome. So hello everyone. Happy St. Patrick's Day and welcome to our third GDN event of the year, Going Cloud, a GCP and Go story. We're really excited. We have a truly wonderful lineup of speakers for you today, speaking about Go and how they took Go to the clouds with GCP. For those of you who don't know me, my name is Angelica Hill. I'm one of the GDN event coordinators and one of your hosts today. Although regrettably, I'm not going to be able to stay for the whole event because work calls, but no worries. I am going to be leaving you all in the very capable hands of my wonderful co-host, the incredible Wilken.
Awesome. Thanks, Angelica. Thank you. It's great to see folks signing up to speak and join us on a regular basis. So hello, everyone. Thanks again for joining. My name is Wilken Rivera. I'm a GDN coordinator based out of Miami, Florida, where it's always sunny. As Angelica mentioned, we have a great lineup today, so I'll get straight to the logistics before we get into our talks. This event is being streamed and recorded for all attendees on YouTube at youtube.gobridge.org. Feel free to spread the word for anyone who might be interested. During this event, we'll be fielding questions in Go for Slack. In the Go GCP meetup channel. So please thread your questions there. We'll be setting it up with speaker information and pinning all the questions in the channel so you can follow along. If you're not on Go for Slack, there is a link already on the meetup page where you can go and sign up. And then once you signed up, you'll be able to join the Go GCP meetup channel. And then as a reminder, if you're interested in speaking at one of our upcoming events, please reach out to myself or Angelica. And in honor of Women's History Month, we're working on our next event already for May, Glorious Go Gals slated for May. So please, if you're interested, reach out to myself or Angelica. All right, now back to Angelica.
Awesome. So I have the absolute pleasure of introducing our first speaker, Matt Holliday. He is a senior developer at the New York Times, working on systems that manage subscriptions. He has over 30 years of experience building reliable distributed systems, including several stints as a principal engineer. He's passionate about helping others to learn. And in this presentation, he'll show us a couple of GAE apps, along with the use of GCP logs, metrics and profiling to monitor and debug the apps. Matt has pre-recorded his talk, so I'm going to be sharing my screen and presenting it to you all, but he is also present here, so we will be turning over to chat to him live after I play his wonderful presentation. So one moment while I share my screen. There we go.
Hi, my name is Matt Holliday, and I'm excited to present to you today on the Go Developers Network. I'm going to talk about Go and Google's App Engine. I want to show you how to deploy an app, but really I'm going to show you some things about how to monitor and debug apps using some tools built into Google Cloud. So I'll say 2 words about myself. I've been programming for a long time, about 45 years. And if you look at this slide, I'm showing technologies that were current when I started learning. Now, it's changed a lot since then. And it's going to change in the future. 45 years from now, who knows what things are going to look like. So please join me and never stop learning. Okay. And as part of that, I'm going to mention one of my projects this year is I'm taking my class that I've taught in person and turning it into a series of videos. I'm putting them up on YouTube. They're rough drafts, and I'd love some feedback. Okay, enough about me. Now, App Engine's what's been described as serverless or platform as a service, right? You build your Go program to act like a web server, but it sits behind a load balancer / reverse proxy that Google owns that takes care of distributing traffic to your app, scaling your app, okay, and providing security. So you don't have to worry about terminating TLS. If you do want to have a custom domain name, you'll need to create your own certificate and import that into Google. And then Google also has a zero trust technology I'll show you in a minute called IAP. Okay, so there is one interesting thing about the way this works, and that is that you don't actually build your software and hand it to Google. When you deploy your app, Google takes your software up into the cloud, builds it and containerizes it there. So it's a little different. To get started, you're going to need, of course, a Google project, okay? And you have to enable App Engine. Now, the button usually says something like create an App Engine app. When you press it, you don't get anything because until you deploy your first app to the cloud, you can't see anything on the dashboard. Okay, so you're essentially enabling App Engine and you have to pick a region for it. And then if you want to follow along with what I'm doing in these exercises, you'll want to also enable monitoring and cloud profiling. So I'm in my laptop and the first thing I want to show you is the repo, mat4biz /go-gae-example. And I'm running everything today out of that. So everything I'm going to show you today is in that repo and you can play with it for yourself. So what's in there first is a default application. There's an interesting thing about GAE. You can have several named apps, but the first one has to be default. And if you only have one app, maybe that's it. What I and some other people have done is we create a dummy app to put as the default app. And that's what I've done here. It's the simplest possible Go web server, right? It just starts up, listens with one route, and responds with hello web. I do want to point out that I look for an environment variable to get the port because Google may want to tell me what port to use. Okay, but otherwise, it's a very simple app. And you'll notice there's nothing Google specific about it. I'm not importing any Google headers to make the app work. Okay, I do, however, have to have what's called an app.yaml file, all right? Because that's how I tell Google what software to take into the cloud and how to run it. Okay, now Google has this notion of runtime for App Engine because they also support languages like Python and JavaScript. And for Go, you have to say what version. Go 1.14 is current, 1.15 is in beta. So I'm going to stick to 1.14. Okay, I have to identify the instance class, and F1 is the smallest thing. It's the free tier. Okay, and my service, of course, again, this is the first service, so it's called default. And because I have 3 services that I'm building out of this repo, I'm going to tell it where to go find the software for the default one, which of course is command/default. Right now, automatic scaling is the default, but I wanted to put in a thing here to say, hey, don't scale past 1 instance. And that's always going to be useful for the default app because it just sits there. But I'm also going to do that for the other apps just to make sure that, you know, for whatever reason, they don't get traffic and start chewing up a lot of CPU and money. And then the last part is actually what's important. This is where I tell it, hey, I want all my handlers to use HTTPS and redirect anybody that comes in with HTTP. Now, if I were building a real web app that had like an index page and static assets and CSS, I would add some more stuff in here and I'll let you go look at examples in the Google documentation, right? For what I'm doing here, very simply, I don't need that. And so I'm just telling it, hey, but do HTTPS for all the routes. And that's it. I don't have to worry about any other part of the security as far as the transport security. That's taken care of. So to deploy this app, I need to go to the command line. Okay, we're going to run a command from gcloud app deploy. And because I have more than one app.yaml, because I've got 3 apps in this directory, okay, I have to specify which one. So I'm going to hit that. And it's going to ask me, do I want to do this? I'm going to say yes. And now it's going to start deploying, right? It's going to upload some files and I'm going to wait. And so we're just going to have a little bit of time here, okay, until it happens. Okay, it's come back to us. And now we can see it updated the app, which is pretty easy because there wasn't more than one file to compile. It also updated the traffic split. So the traffic will all go to the new app and we'll go see that. So if I go back over to Google, right? I have a dashboard for App Engine And one of the things I can do is I can look at versions. So we'll come and look at versions, and it has the versions for default, the one that was already there and the one I've just added. So what I'll do now is I don't like to keep around old ones, so I'll delete it. And I'll just click on that one that's not has any traffic. And you'll notice I could also adjust traffic splits here. I could move traffic from one to the other or split the traffic between the two versions. In this case, they're identical. But I'm just going to delete the old version so it won't run anymore. Now, the other thing I want to show you, and you can't do this until you have your app up and running, is IAM is where we do identity management. And under there's something called Identity Aware Proxy. And if I go there, it allows me to put an added layer of security. Okay, so my apps have HTTPS, but they're open to the world unless I lock them down. And this is one way to do it. IAP is a, how satisfied? Yeah. IAP is a zero trust model. And so I'm going to go and take all of my apps and go down here and look at roles. And what I've done is I've added a couple of IAP secured web app users. And those are the only user IDs that can actually get into my app, okay, which is really me. And I could add other people if I wanted to. In production, you wouldn't add individuals, you would add organizations. In other words, you would create an account in your project for your client microservices, the ones that talk to you, and you would add them in here, and then they would be able to access your app, but it's still on the internet and other people can't. So now we'll look at one of my apps, and I'll go over here and look at the services. It gives me a list of the services that I've got running, and if I click on the To-Do app, it's going to take me there. Now, I need to give it something more. My To-Do app, it doesn't really do to-dos. It goes out to a server from a company called typicode.com. They run a server that just serves up REST for a fake To-Do app that allows you to do some testing. Okay, so my little proxy web server, if I type in the number of a to-do here, it's going to go out and get it from Typicode, decode the JSON, and turn that into a web template. It's not very exciting. But what it is going to do when it returns, it has the information that came back from Typicode, and it has one more thing, because I'm putting a trace ID into it, right? Now, this is for logging, or at least for me, it's for logging. If I go and look at the log viewer, and I'll update this, right? So down here is my latest log, and if I go look at that, I get a log from App Engine every time there's a request. It's got the route, it's got where it came from, the type of browser, how long it took. It took a while because it needed to wake me up, okay? How many bytes were returned, and so on. Okay, fine. Now, the log also has in it this trace ID, okay? And that trace ID comes in a header. If I were to look at the header of the request, we're going to find it there. And what I can do is pull it out and use it in my own logs. And I'll show that it's an easy way to correlate the logs. In fact, let me start there. So if I go back to my To-Do app, right, I've selected this trace ID. I go to the log viewer, and I can just type it in the search field. And now it's only going to show me logs with that trace ID. It's random enough, I'm not going to get any other junk. It's not very exciting to have two logs. But if I had a bunch of logs on a request, and I have a lot of requests per second, then suddenly being able to type a trace ID and correlate them is very convenient. So how do I make that work? Well, I'm going to go look at the handler for my To-Do app, right? And it has some other stuff in here. It has the structure of the to-do, and it has the code to go out there and, basically, I'm doing a request to the Typicode server in my server, and I get back the JSON, right, which I decode, and then I put that into a template, right, and I'm just adding one more thing to my template, which is this trace ID, which is why it shows up in the web. Now, if I were doing a REST API, I could send it out in my REST API as part of the data, or maybe even metadata, or I could make it an attribute from a GraphQL data structure. I've done that. But in this case, I'm just showing it on the web. And if I look at how that comes, right? So there's a standard header, and I say standard for Google App Engine, X Cloud Trace Context. The header is going to be in every request. And I have a little function here that I go and take the request, find the header that matches that key, pull out the data. It's a string. Now, it turns out in practice, it has this trace ID slash and some other stuff. And I don't care about the other stuff. So I just split it at the slash and take the first part. And that's always going to be safe. Even if the split is just one item, I can index the 0th part of that. So it's always safe. I get the trace ID. And now I just come down here and put it in my logger. Now, I'm using the standard library logger. So I'm just taking the writer from the default logger and making a new logger around it. So it goes to the same place with the trace ID and these flags that say, hey, put this into it and put it, in front of my other stuff, but after the date and time. All right. And now every time I print a log, and I've got some logs in here for errors, but down here I've got a log. This is the one you saw. When that log prints out, it's going to have the trace ID in it. Now, in production, I probably wouldn't use the standard logger like this. I would use some fancier logger that probably put out JSON, right? And then the trace ID would be a property of that JSON. And again, that's fine. When it gets to Stackdriver, where am I, right? If I had a log with JSON stuff, I would see a field here, JSON payload, and I could look in it, but I don't even need to. Once I type this ID on the search bar, it's going to find it regardless of where it was, whether it was in the text or in the payload from Google's logs or the payload from one of mine. So there you go. That's an easy way to put the logs together. It's very convenient. Now there's something else going on in this app. And I'm not going to dig into it, but if you go back and look through here, I have a bug. And my bug is going to cause this app to leak Go routines. So the question is, how do I see that? And I can do that by going over to the profiler. All right. So GCP has a profiler built into it. I've picked my app, the to-do app, and I've asked it to go look at, the drop-down says threads, but when you look down here, it says Go routines. And what's interesting is, unlike the built-in pprof, this one has a heat map. So I'm looking at a heat map, and this number over here is going to grow. If I were to run traffic against this, I'm not right now, it's just going to keep growing. I'm going to see more and more Go routines. And they're basically sitting, if I look at this stack, they're sitting on a polar. They're sitting waiting to read something. Well, okay, why? Well, because I didn't properly close them in my app. Okay, so if you've taken my class, you know the number one way you leak memory in Go is to leak Go routines. And one of the ways to leak Go routines is to leak sockets, right? So if you don't properly close the response body in your handler, you're going to leak sockets and they're going to show up here. And the right way to do this is not to wait for your app to crash and go figure out why. Okay, you build your app and you test it. And part of testing is load testing. So you run some traffic against your app and you look at it in a tool like this and see, hey, do I have a number of Go routines that's just growing? Because if it's growing and not shrinking, or it grows and then you stop traffic and they just sit there, okay, you have a problem. And this is how you find it. Now, how did we get this part? And to get this part, we need to add something to our program. So I'm going to go back into my to-do app, and I have another file called monitoring. And let me actually go to main first. In main, I have a little bit of code where I call init monitoring. That's a function I wrote, okay? And if I skip back and look at it, this is where I do, in fact, have to start calling a Google API, right? I'm going to import the profiler API, right? I'm going to go out and use a couple of environment variables to find my project and my service, put them into a config, and then I pass my config to profiler.start. And that's all I have to do. That's enough to connect my App Engine app with Stackdriver so that Stackdriver can get profiles out of my app. Okay, and we can look at them. We can look at the Go routine one, and later in a couple minutes, I'll show you how to look at CPU time. But this is all I had to do. But once I do this, now I have some Google specific code in my app. Right, so I want to go look at yet another app real quick. So I want to go back to my services, and I've got another one here called sort. And actually, I think it's already open. All right, and sort is actually an animation of sort algorithms. So I'm going to hit insertion sort. And again, this is going to take just a little bit of time. The server may be asleep, and this is slow on the kind of machine I'm running, but it's going to animate the insertion sort, right, from top down. So if you start at the top, you've got the unsorted array, and every row shows a step as we work our way down until we end up with a sorted array. Okay. This is the insertion sort, for example. I'll let it finish and we'll run another couple. Right. And I've got also, if you look at the code, you can say whether it should loop the animation or not, and you can actually set the delay between frames. But right now, I'll just run insert, it's done, right? I've got a quick sort. This is not the fast quick sort, so it's going to take a little bit of time. And then we'll run more and more after that. And I'm doing this so I can run a bit of traffic and we can measure it. So here's quick sort. It works a little differently. It's doing sort of blocks as it does partitions and chunks and stuff. Okay, and this one works from the top right down to the bottom left. But we'll see as we go, we get more and more sorted, and we're almost there. There we go. That was the not so fast quick sort. I've got another variation that's much, much faster on an array like this. We'll run that real quick, and boom, it's done, right? That was the quick sort. Okay, so why am I doing this? Well, I can go look at the traffic. If I go back to my dashboard, so this right here gives me one way of looking at traffic. Okay, I can see that I've got requests in my app. I can drill down a bit more than that. And I can do that with something called the Metrics Explorer. Now, this works because there's some metrics. Google does have some metrics of their own. So I can go pick a Google one that says, well, how many requests went into your App Engine app? But I've also defined a couple of custom ones to show this, and we'll show you how we set it up in the code in just a sec. But here we go, and I have them broken down by route. So how many inserts and Q sorts and Q sort 3 and so on. I didn't run a lot, so it's not terribly exciting. Okay, but I've picked my metric. I don't think it'll pop up. Yeah, well, it's very small. You probably can't read that. And I've also said, hey, group it by route, and I'll show you how to do that. But what I've also done is created a custom dashboard. And again, I've done the custom dashboard with my custom metrics. So I can see, for example, requests per second. And it's just a little bit behind the time. It takes a little bit of time for the metrics to get out of the app and through Stackdriver. So they'll show up here in a sec, right? I've got one for requests per second, and I've got one that shows the P99 latency. Okay, so where did those come from? And the answer is they came out of custom metrics that I built into the program. So if I go look at the sort program, right, I've got my init monitoring. It's a bit more complicated. So first, I've got several more things I'm importing. There's a package called Open Census, and it provides a way of defining custom metrics, and it has tools to export them to Stackdriver and other providers. Okay, so I've imported those, and I'll use them. Okay, now in order to group my routes, I have to define a key to do that. So I've got a variable that represents the key for the routes, and then I've got a couple of variables that I'm actually going to increment. That's where I'm actually going to peg the stats as I do requests. Fine. Right. The part up here is the same where we start the profiler. And now we get into the code that's new. The first thing I've got to do is actually create a new key for the route. I'll call it tag.newKey. And a tag is something I'll apply to metrics. I'll show you that in a minute. And then I've got to create a couple of views. Now, the view is the way we export the metrics. It encapsulates one of these counters and says how to interpret the counter. So the request view encapsulates the request counter, okay, says it's going to be a count. So we're going to just sum them up. And also I've got a tag here with my route key so I can group them by route. The request time view is a little different because it has a distribution. And so this allows me to say, hey, I'm going to measure it with some time intervals, put them into buckets, and deal with it that way. So I'm not just adding up the time total, I'm measuring it in terms of, well, how many were at 1 second and 2 seconds and so on. Now, I would normally do this at the level of millisecond, all right? But this animation app and the very small instance I'm running on It's not very quick. And again, I can break those down by routes. So I've got the route key again here. Okay. In order to use the views, I have to register them. So I call view.register and pass in my 2 views. Okay. And then I need an exporter. The exporter is the part that actually is Stackdriver specific. This is where the internal stuff of Open Census gets turned into something that Google can handle. So I go and create an options with my project ID. And my project ID, again, I got it up here by looking at the Google Cloud Project Environment variable. Right? So I call for a new exporter. I register my exporter. And then the last thing I do is I set the reporting period. And it just says, how often should Open Census try to push metrics to Stackdriver? And 60 seconds is a pretty typical number. Great. So now I've defined my custom metrics, but they don't do anything yet. If I want to do something with them, I have to use them when I process requests. So I'm going to go over and look at my handler code. And in there, I've got a chunk of middleware. Okay. Now, my middleware is doing some other stuff, right? I'm getting the route from the path, and I'm putting it into the context. So the way when you tag a metric, or excuse me, when you peg a metric, you'd use the context. And to put a route tag on it, I need to modify the context, right? So I call tag.new, which is actually going to return a context. I use the incoming request context, and I'm adding to it this route key that says, hey, you know, find the route, which I've already broken out from the URL, and mark it with this route. So that way they can be grouped that way when they're displayed. Okay. The trace ID and logger stuff we've seen before. I've also got a little trick called a counting writer that lets me figure out how much output was sent back in the response. Not very exciting. Okay. In order to do time, I've got to start a timer. So I go and get time.now, right? And then I do my serve HTTP, and then I calculate how much time was elapsed, right? So I'm going to peg here the count of requests with stats.record. I pass in the context, and I pass in this variable that's the measure of the number of requests. Okay, and again, that was tied to a view and tied to an exporter, right? When I calculate my time, usually I resolve it as milliseconds. Now, because here I know that I'm really slow, I'm going to divide by 1,000 and report it in seconds. This is just weird, and I'm doing it for this example app. So I do a stats.record, and this time I'm adding something to request time. Again, this is going to be put then in the request time view and shown as a distribution. All right, latency. And then I can look at, you know, what's the average latency or the P95 or P99 latency. Great. So this middleware gets run every time I run a request, regardless of, you know, which type of sort algorithm I'm running against, right? We'll find it, pick it out, put in the tag, record the metrics about this query, and they'll build up. And again, that allows me to go back to this dashboard, for example. And there's actually a little button here. If I turn it on, it'll start running in real time. Okay. So it shows me this most recent stuff, right? How many of each kind and so on. And some latency stuff over here. Pretty slow because, you know, my app was asleep and had to start up. And these sort algorithms are not really fast on the little instance I'm running. Okay. Now there's one more thing I can show about this app, and that's the CPU profiler. So I'm dropping into the profiler again. And in this case, my drop down is for CPU time, and it's the sort app. And if I look at this, you know, over here, there's just a bunch of background junk. This stack over here is all the stuff related to serve HTTP. And it gets broken down about right about here based on the route. You know, if I call the insertion sort, it's pretty slow, or I spend a lot more CPU time there compared to like a quick sort, or particularly the fast quick sort, right? So I can actually see the speed of my sort algorithms that I'm animating by how much CPU they're consuming, and particularly the relative amount of CPU. The fast quick sort's much faster than the others, and they're much faster than insertion sort. Okay, right? And you can do other things in profile. I'm not going to look at memory right now, but you can look at memory with it. And again, all I had to do for profiling was to make one call to start the profiler. For the custom metrics, I'm using the Open Census package. I had to do a bit more work, but it's pretty straightforward. And once I've got some of that set up, if I want one more metric, the delta is pretty small, right? You just got to figure out, okay, where am I going to peg that metric in my program? But having that is very useful, right? Again, I could probably create this dashboard using metrics from Google. But if I also want metrics like how many queries do I send to other microservices, or how many times do I go to Redis, or how many errors do I have going to the database, I'm going to want custom metrics for that. And I find the best way to do that is to use Open Census. There is also a way to do log-based metrics. I don't like them. I think they're fragile, because if somebody changes the text of your log, well, maybe it doesn't match your expression anymore when you're trying to filter the logs for a log-based stat. So I think the metrics are a better way, okay? And of course, we have the log viewer, and I can change the log viewer to show me the sort app, right? I can just go and say instead, I could have told it all the apps, but right now I'm just saying, hey, look at one or the other. And here are my logs from, running like quick sorts. And again, they've got trace IDs, and I've got trace IDs here, okay? Now, I didn't put a trace ID in the image that I displayed in the web browser. That's not very convenient. But if I were doing some sort of REST API again, I might. Because if somebody comes to me and says, hey, I had this problem, and here's the trace ID from your response, I can take the trace ID, throw it in the log viewer, and immediately find the logs and see, oh yeah, well, it didn't connect to the database properly when it tried to handle your request, or it timed out or something. Okay, so these are some techniques for debugging apps in Google App Engine. And I've also showed you how to actually deploy an app and manage it. As I wrap up, I just want to point out, I've also got, I have some other repos for classes that I teach, but I've got a repo with Go resources for learners. So it's got a collection of some books and articles about Go and videos, particularly videos from old GopherCons, and a few videos and articles about building software in the cloud and so on, and software development techniques. So it's interesting stuff, okay? And then finally, I just want to say thank you for your time. And here's some contact information if you want to get a hold of me, right? And if you want to search for the videos, I either had the playlist earlier, or you can search on this funny little tag here. You'll have to hold down the Option O to spell it right. Anyway, again, I'm very glad to have this opportunity to present to the Go Developers Network, and I hope you enjoyed it.
All right. Thank you so much, Matt. You can go ahead and, yep. Thank you, Angelica, for playing that video. Great
one. So I'm keeping an eye out on the Gopher Slack channel for questions, as well as the YouTube channel. And I know we had one that I think you got an answer to, but I want to check. There was a question: what was the name of the REST service that you mentioned near the beginning? I think someone kindly posted in a link. It's on placeholder.typicode.com, but maybe you could talk a little bit more about where you found that.
Oh, I've used that for so long, I can't remember how I found it. It's just very handy because it's a way to generate some JSON that comes back to you in a REST answer. So if you're building a little program, and I use this in my class, I use it to demonstrate, okay, how do I decode somebody else's REST API response in JSON? So you can just go out to it and give it 1, 2, 3, 4, and it comes back slightly different answers depending on what you do.
Awesome, thank you. If anyone else has any questions, I'm just going to look on the Slack channel and the YouTube link as well.
Yeah, I don't see anything in Slack, Angelica. If you want to just do a quick spot check on YouTube.
Can we get the links in the Slack channel? So that'd be great. Maybe after this, Matt, if you could post in the links that you had mentioned throughout your talk in the Gopher Slack channel, that would be awesome. Oh, there we go. Wilken was on it. Great. Well, if there aren't any questions live, Matt has obviously shared his contact information. Please do feel free to reach out to him. Also, I would highly encourage any newbies to check out his learning resources. I personally have dived into them and they are great. So really, please do dive in and check those out. Thank you so much, Matt. Really appreciate it.
Thank you.
Great talk. And I will pass over to Wilken. Thank you for our next
Okay. All right, awesome. Thank you, Angelica. Again, Matthew, thank you so much. Really appreciate it. Yeah, we're gonna go ahead and continue on. Really excited to introduce our next speaker. His name is Valentin de la Place. He's a senior developer for backends, databases, and cloud architecture, platform, and algorithms over at Google. Today, he's going to be talking about the many choices that we have when it comes to GCP, and more specifically around Go web app serverless options in GCP. Valentin, I think you could go ahead and unmute yourself and start your video. You should be good to go. Yeah.
Hello, I will be enabling video right now.
All right, awesome.
Wilken, can you see me?
No, not yet. I can't. It seems like you might have video on, but you may have a shield over your camera. Or
No shield on my camera. Let me see. I have multiple cameras, but no shield at all. I'm gonna stop video, and then. Can you see me now?
No, not yet.
Okay, so I might have to just quit Zoom and come back.
All right, sounds good. Okay. Awesome, great. All right, we'll give Valentin a few minutes to jump back on. I'm going to do a quick spot check in the Slack channel to see if anybody has any questions about anything. Right now, I think there was a question before about how do we reach out to Angelica or I for talks. Again, you can hit us up on Go for Slack. I'm Wilken Rivera on Go for Slack. I'm also Wilken Rivera on Twitter. And Angelica is Angelica Hill on Go for Slack, and Angelica Hill on Twitter. So making it kind of simple in that sense. For email perspective, I'm wilken@gobridge.org, and Angelica is angelica@gobridge.org. So if you're really interested in speaking or interested in helping out, I think, we'll love to have you. Just feel free to reach out. Yeah, I guess, I don't know. Let me do a quick check to see if anybody has any questions. Yeah.
As we said at the beginning, it's not a real virtual event unless there are technical difficulties. Oh my gosh. I also saw someone commented on my lovely pink gophers. I would say you can definitely, back in the day, they used to give them out at the Go conferences, and I just happened to just get pink ones. But I'm sure if you wanted to get one, you could track them down somehow. I've been searching for more. I'm trying to make a whole colony of gophers behind me. Let's see.
I tell you, Angelica, I think for the next event, I'm going to get a better machine. My machine is crawling right now. I hope that
hello?
Yeah, if people can hear me and see me okay. All my CPUs are pinged. Yeah, so I don't know.
Well, I can see and hear you fine. You seem to be posturing along nicely. Right. So
awesome. I love it. So let's see. I'm just waiting for chat to load up.
I'm hoping
that team joined again. I realize.
Let's see. Valentin. Oh, there we go. Yes. Promote to panel. Yeah. I'm so sorry. We've just been like chatting away.
Yeah. Can we get a link to this action? Absolutely.
Hello.
Okay, cool. We can hear you.
Hello.
Can we? Yes, we can see you.
Yes.
You can see me. Cool.
Yes.
Win.
Would you say the sound is good or?
You're on mute, but you're unmuted. It sounds good.
Hey, Wilken, Angelica, would you say the sound is good on my part or pretty poor?
Yes, I can hear what you're saying. I feel like it's good.
Okay, this is the web client and I don't trust it, but we will proceed anyway.
Give it a go. You never know until you
Okay.
try.
Awesome.
Yep. So I will share my screen. This one should be good.
Awesome. Can see it.
You can see my screen, great.
Yes.
So I will just start presenting. Hi, my name is Valentin. Today I'm here to talk about Go and serverless in Google Cloud. But first, a few words about myself. I used to be a Java developer, building mostly web backends. Then around 2012, I discovered App Engine and the Go language, and then the Go runtime available in App Engine. This was refreshingly different from what I knew about web development and hosting. I loved it. That's when I knew that I wanted to work in serverless environments long before the word serverless was used in that context. Google Cloud is what we call a public cloud. Today, I'm talking only about technologies and products available in Google Cloud, although, of course, some of the concepts exist in other cloud vendors as well. Google Cloud offers many services to consumers and businesses. The umbrella name Google Cloud actually covers two distinct worlds. On the right, we have Google Workspace, formerly known as G Suite and formerly known as Google Apps for Work. It's a family of productivity and collaboration tools to do email, spreadsheets, etc. On the left, we have GCP for Google Cloud Platform, a suite of computing services for business customers. All of the serverless computing products are on the left side. They are part of GCP. There are a few distinct acceptations of the word serverless. Today, I'm referring to these three specific services, all of which allow you to deploy some Go code to handle incoming HTTP requests. App Engine was the very first compute product in GCP, released in 2008. Cloud Functions and Cloud Run came much later. My boss, Greg Wilson, has written a handy list called Google Cloud Products in 4 words or less, from which I took these extremely short definitions. App Engine is a managed app platform, mostly used to build dynamic website backends. Cloud Functions is functions as a service. It lets you specify the code to be executed in response to an event, which can be an HTTPS request, but there exist other kinds of triggers as well. For example, do something asynchronously when a new file has freshly been copied to a cloud storage bucket. Cloud Run is a serverless platform for stateless containers. It's perfect for any application that can be expressed in terms of a HTTP server inside a container. Serverless platforms have a lot of nice properties. They scale automatically to serve thousands of concurrent users if you happen to have a sudden traffic spike. They also scale down to 0 instances, which means that I don't have to pay anything when there is no traffic. I pay only for the resources that are actually in use at any given time. But my favorite thing about these platforms is that they are managed. They are managed by the cloud vendor, not by myself. This means in practice that I never have to worry about the underlying hardware infrastructure, network configuration, and OS security patches. I prefer to focus on my app. When you go serverless, you need to design your app carefully in a stateless way. This means that the specific server instance that processes a given request does not hold data and is not regarded as a source of truth. This is a fundamental property of auto-scaled serverless architectures. The user data, if any, lives in distinct stateful components, which can be a database or a file storage or a distributed memory cache. Basically, this is the kind of things we want to deploy, a web server written in Go. This code says two things. First, register an HTTP handler function. This one is just a hello world. And two, listen to a port, by default the port 8080. Serverless is a misnomer. Of course, there are servers. I prefer the term serviceful because the managed infrastructure provides a simplified access to a wide range of cloud components that don't live inside the serverless instances, which are here. We want to programmatically use these services here from our Go web app here. To achieve this, it would be awesome to have a ready-to-use Go client library for them. Good news, they all come with high-quality client libraries for Go and for several other popular languages as well. Sometimes a third-party popular library does the job. For example, any MySQL connector module is fine to connect to a Cloud SQL database with MySQL flavor. And any Redis client is fine to connect to memory store with Redis flavor. As an illustration, I wrote and deployed 3 versions of a simple app called HotMaze, designed to transfer a file from a computer to a mobile device. First, we drag and drop the file from the hard drive to the HotMaze webpage, for example, a photo of a kangaroo. The file is uploaded to the cloud. The web page now displays a QR code, which encodes a temporary public URL to access the file from the cloud. So when the user scans the QR code, they get the kangaroo. I'll do a quick demo. In my file explorer here, I should have the photo of a kangaroo. I have the HotMaze web app in my web browser here. So what I can do is to drag and drop the kangaroo. There should pop up a QR code. So now I will scan it with my smartphone. Okay, looks good. Yes, I did get the kangaroo. It worked. Very cool. Let's deploy HotMaze to App Engine. So do I have a command line here? So I already have the gcloud command line tool installed and configured with my account and my current project. This is my account and this is my current project, HotMaze. I will just run gcloud app deploy. And I'm deploying to a new version of the app. Oh, never mind. I will stop that and add the command time just to see how long it will take. Okay, so I'm deploying to a new version of the app, which will handle 100% of the traffic. My previous versions still exist and are still deployed, but they don't serve traffic anymore at the main app URL. I should have the Google Cloud Platform Web Console here somewhere. Okay, so here are the versions deployed for HotMaze, and the version that has all the traffic is called B1 here, and I'm deploying a new one with that has the name, the date of today. Okay, that shouldn't take very long, hopefully. The code structure of my app looks like this. it's a standard Go web server, which contains both the static assets and the dynamic handlers. And I have an executable here, main, in a subfolder of CMD. This is all very standard in Go. Still uploading, okay. Because it's a standard Go web server, I can build it and test it locally. I could also decide to host it somewhere else without changing the code, as long as I'm not using any proprietary services. This specific version of HotMaze uses the proprietary service cloud storage. So right now it's meant to run inside GCP. Here is again the command line to deploy from the source code. It's really simple and it's great. Let's see if it's finished. Yes, it took 1 minute 30 to deploy, and I can visit the app at this URL, app browse. Okay. Okay, maybe I shouldn't have done that. Never mind. At least it's deployed. Okay. Now let's deploy HotMaze to Cloud Functions. Cloud Functions is not exactly a website hosting option. We are deploying all the dynamic handlers to Cloud Functions, and for the static assets, HTML, JS, CSS resources, we will deploy to Firebase hosting. The command to deploy one function looks like this: gcloud functions deploy, then the name of the function, and then a few parameters. Here I'm deploying only one function. They all must be deployed separately, and I happen to have 3 functions in my project. If I want to redeploy the static assets, I will launch Firebase deploy. Oh, I forgot to ask how long it takes with time. Sorry about that. I think redeploying the static assets with Firebase is pretty fast, like 10 or 15 seconds. Yes, 8 seconds only. And it's a little bit longer to deploy one function. It says here up to 2 minutes. So typically between 1 or 2 minutes to deploy one function. As I mentioned, this command line for gcloud function must be launched as many times as I have functions, but only once for Firebase deploy. 2 other talks today will cover cloud functions, one by Frederic and one by Misha. So I won't be talking anymore about cloud functions. Please stay tuned. Now we'll deploy to Cloud Run. Cloud Run is an amazing piece of technology released 2 years ago. With Cloud Run, you have the freedom of infrastructure as a service and all the advantages of serverless at the same time. With Cloud Run, your code is a regular Go web server, just like with App Engine. Typically, you would test locally in a container with Docker. Deploying to Cloud Run normally involves 2 steps. First, you push an image revision to a container registry or artifact registry. This can take about 2 minutes. And second, you ask Cloud Run to deploy this specific image. This last step is fast, usually 20 seconds only. So I'll do it right now. Yes, I forgot to mention that in order to build a container, okay, Cloud Function has finished deploying. That's cool. In order to deploy a container, first I should build the container, but first I should build my Go application, because I will deploy a binary actually. I'm not deploying from source right now. So here I'm building my server. Then I will build my Docker image locally. Okay, success. And then I will submit, so deploy this build to container registry. I will kill it and ask how long it takes. Time gcloud builds, submit. So as I mentioned, this part is the longest one of the deployment process. It can take 1 or 2 minutes. Okay. So these are the commands that, okay, those are the 2 commands, one to build the Go web server and one to build the Docker image locally. And those are the 2 commands, one to deploy to container registry and one to deploy to Cloud Run. I shouldn't have shown that, but actually, it's been a few weeks that then we can now do all of this in one single command, which is still in beta, that allows us to deploy from source. So with only one command that will take 2 to 3 minutes, I can deploy my Go web server from the Go files without having to specify anything extra to build the web server, build the Docker image, publish, so push the Docker image and deploy the Docker image to Cloud Run. I tried it, it worked, and it was amazing. So a word about staging in all of the serverless options in Google Cloud. Staging is very important. It's about deploying the app for testing, Q&A, or doing experiments, but not to production. So it's possible with all of these products to deploy to different versions of the app or of the function. And some of the service dependencies like memory store or data store, etc., some do offer some kind of multi-tenancy, which means isolating data with namespacing, etc. But in my opinion, it's too easy to shoot self in the foot. So my advice is this, you'd better use a distinct isolated GCP project for staging. This is the most straightforward and safe way to achieve isolation from production. Just my advice. Concurrency. All of the options discussed today have the ability to spin many instances handling requests concurrently. Each Cloud Function instance is able to handle only one concurrent request, so you have to keep that in mind. On the other hand, each App Engine and Cloud Run instance may handle many requests concurrently without starting extra instances. The max concurrency in Cloud Run is 80 by default and can be configured up to 250, I think. This is a really important feature because a typical handler spends very little time using the CPU and much more time waiting for the database result or other cloud services. So even during a request processing, it still spends a lot of time idle, which is a good opportunity to let other requests use some CPU and launch their own database queries and service calls. Now a word about security. With App Engine and Cloud Function, you basically deploy from code. And in Cloud Function, you can even type your code directly in the web console. Do I have this here? So this is the list of the functions, of the free functions that are deployed in my project in the Cloud Function case. And if I look specifically at one of them, I can see the details when it was deployed, and I can even see the source. All the source files involved are available in the web console. So for App Engine and Cloud Function, we deploy from code, which means that we don't specify much in terms of operating system, runtime environment, etc. Which means that we don't have to worry a lot about patching the operating system and the runtime. And so in case of new discovered vulnerabilities, we only have to care about our own code and the specific dependency versions, the Go modules or Go package versions that are our dependency. If we need to bump a package for security reason, then it's on us, the cloud practitioner, the customer, to fix it and redeploy. For Cloud Run, it is much more powerful. I mean, you can do many things in a container, and that's amazing. But it also means that you have to take care of the security patches of the image base of your base image and all of the binary dependencies that you might happen to depend on. So consider deploying often, at least for security reasons. Now a word about cold start. A cold start or loading latency happens when a specific request has a higher response time because it's waiting for an instance to start. This problem, in my experience, is specific to serverless platforms. So it's good to keep in mind that when scaling up from 0 to 1, obviously one instance needs to be started, and it's usually fast to spin an instance with a basic Hello World server in App Engine or Cloud Run. It can take less than 1 second. But if your app happens to have a lot of dependencies and initialization, like let's say 15 seconds of initialization, then sometimes the end user will have to wait for 15 seconds before getting the response, the HTTP response. That is not fun. It is a serious problem. There are many ways to mitigate this problem, and I encourage you to explore them if you decide to go serverless. To conclude, we've seen that the 3 main serverless compute options in GCP work very well with the Go language. Cloud Run is like an evolution of the original App Engine, with most limitations lifted. Basically, inside a container, you're free to do whatever you want. The ability to include on any arbitrary binary dependency is extremely powerful. For example, in my previous job before Google, we needed to parse 3D files from SketchUp. The only effective way to achieve this was to use the official SketchUp SDK, which happened to be a Windows DLL. So at first, we used a fleet of Windows servers just for that purpose, which was not super convenient. Then we successfully used the utility called Wine to execute, it's an emulator, a Windows emulator for Linux, to execute the DLL from a Linux machine on Google Compute Engine. So now we had a fleet of Linux servers to manage, and it still involved quite some toil. Nowadays, this kind of workflow is possible easily in a serverless way with Cloud Run. Wrap the Linux distribution and the DLL and Wine and the Go web server inside a container, and you're done. And this is truly amazing, in my opinion. That's it for today. Thank you very much for listening. If we still have time for questions, then I'd be happy to take them.
All right, Valentin, thank you so much. Such an awesome presentation. Thank you. I hear a lot about Cloud Run when I work on the Packer team, and we get a lot of issues that come through the wire for Cloud Run. So it's really nice to kind of get some background on it and learn a little more. So thank you for that. I'm going to check on the Slack channel to see if we got any questions coming in. Just to remind everyone on the listening in, all the questions are being threaded in Slack. So please, if you have any questions, please feel free to post them there. And if you can't do so now, maybe Valentine can come by later to respond to them. So let me see what we have, if anything. So one question that came up is, how are the pricing differences in your experience apart from the online information?
Yes. So can you hear me, Wilken?
Yes, I can.
Okay, so Google Cloud obviously is targeted at business customer and enterprise, etc. Unfortunately, this is not exactly my experience. My experience was as a practitioner at home for fun, building websites and deploying them. And I will tell you what happened. I built a few applications, a few websites, and one of them had a little bit of success. It's called programming idioms. This one is deployed to App Engine, and it has some traffic daily, about 2,000 visits. One visit is usually like 10 requests, so that makes 20,000 requests per day. And 2,000 visits per day is about 50 or sometimes 60,000 visits per month. And what happens is that I don't know the true pricing because it cost me nothing. I mean, App Engine and Cloud Function and Cloud Run have a very generous free quota. And my website, even with some traffic, thousands of visits, fits comfortably within the free quota. So at the end of the month, my bill is sometimes $0 and sometimes 10 cents for App Engine and the data store. So my experience is that it's extremely cheap. I have troubles getting to pay anything because of the free quota. But I heard some experiences about folks who tend to find serverless options more expensive than the infrastructure alternatives. And so what can sometimes happen is that you build an app, you spend months building the app and then deploying and then getting some success. At first, you pay nothing because of the free quota. Then you pay a little, and maybe if you have a lot of success, you will pay expensive. And this is a good news. That's a very good problem to have. And so some customers in that case, to reduce the cost, successfully rewrite and redesign the same application to run, for example, on a GKE, on a Kubernetes. Or on their VMs or other container-based solution, but usually they keep the auto-scaling capability because it's really useful. If someone talks about your app in a popular outlet and you get a very high traffic spike, you don't want it to go down. You prefer it to keep working. So some of them have success reducing their cost by migrating to Kubernetes. It's more complex, it works, but the path that I went was to optimize the heck out of all the serverless options in Google Cloud, leveraging Memcache, leveraging the data store, making JSON payloads and HTML payloads as small as possible, and making mostly text-based pages just to have everything small and cheap. And it worked really great for me. I'm still paying nothing each month.
Oh, awesome. Great answer. Lots of good details there. Happy to see that even as you start to scale, things are still relatively cheap. So that's good. I guess the big takeaway from that is just like experience, the pricing may vary, but it seems like the free quotas are very flexible enough to handle, a decent amount of scale. So awesome.
In my case, yes.
Yes. Awesome. Well, I think, if anything, looking at Matt's presentation and some of the things you covered here, there's a lot of tools to sort of get observability and look into ways, to see how things are growing, so you can kind of, think about pricing and prepare for that. So far so good. It looks like we have all the tools we need so far to, keep the pricing down. Great. So I think I have no other questions that come through that came through, but Valentine is on Go for Slack. So please, if something comes to mind later on as other speakers are talking, please feel to drop it in the Slack channel. We're in a Go GCP meetup, and we'll try our best to help you out. All right. Awesome. Thanks
Thank
again,
you,
Valentine.
Wilken.
I appreciate your time. You got it.
See you soon.
All right. Likewise. Hey, Seth, how's it going?
Hey, Wilken. Hey, Angelica. How are you doing?
Yeah, pretty good. Thanks. I think Angelica is had to step away for a little bit, but she'll pop in a little later. So
Well, then I take back my hello. I will reserve it for later.
There you go. There you go. Now all is good. Happy to be here hosting this on St. Patrick's Day. Happy to have you on. So really excited to to introduce you. So again, thanks for joining us. For those who don't know, this is Seth Fargo. He's an engineer at Google. He previously worked at HashiCorp, Chef, Software Custom Inc., and some Pittsburgh-based startups. He's an author of Learning Chef and is passionate about reducing inequality in technology. When he's not writing, working on open source, teaching, or speaking at conferences, Seth advises nonprofits. So today he's going to be speaking to us about the gotchas of using Go to reduce the spread of COVID. And without further ado, Seth Fargo.
Cool. I started sharing my screen. Can someone confirm that you see a slide that says Google Cloud?
I see not a slide that says Google Cloud. I see the YouTube channel and your terminal.
Well, that's
and now your messages.
all right. That would be incorrect. How about now? No. Sure. How about now?
All right, all good.
All right, cool. Give me 1 second. All right. Hey, everyone. Thank you so much for having me. As said, my name's Seth. I work at Google. I work on the developer relations team, actually the same team as Valentin, who did the previous presentation here. Today, I'm going to be talking about something a little bit less Google Cloud specific and more about the Go programming language itself. As many of you know, we're kind of in the middle of a pandemic. And during that, some people took on slightly different job responsibilities to try to get the pandemic under control. And I did the same. I didn't like change jobs or managers or anything, but I shifted focus away from my normal day-to-day activities and started working on a project called Exposure Notifications. If you're not familiar, Exposure Notifications is a joint effort between Google and Apple to help governments and public health authorities fight the pandemic through digital contact tracing using iOS and Android mobile devices. I won't go through the whole program, but in short, when a mobile device is in proximity to another mobile device, in other words, when two humans are in close proximity, they exchange random rotating identifiers via low energy Bluetooth. And when a user tests positive for COVID, they can opt to upload those random IDs to a central server. And then on some fixed interval, usually every night when you're connected to Wi-Fi and plugged in, other mobile devices download those keys from that centralized server and perform a local on-device match. If there's a match, it means that you came in contact with someone who has tested positive for COVID. There's a number of parameters that are set by the local health authorities, so this is a little bit of a simplification. If there is a match, this generates what we call an exposure notification, which is a pop-up on your iPhone or Android device that says, hey, Seth, we think you've been exposed. We don't know who exposed you because the server only ever has random IDs. We never have identifiable information. And you don't know who exposed you because you only just get a notification that says you've been exposed in some recent time period. So because of this design, it means that the server never knows which keys you have or how many matches have occurred. And the client does all of the matching, whether it's the iOS, iPhone, or an Android device. A lot of the work goes into the mobile client itself, right? The operating system. But I don't actually work on any of that. I work on the server side. And we've written 2 server components, both in Go. that leverage a serverless architecture. And I want to talk to you today through some of the challenges we experienced and some of the mistakes that we made in building a piece of infrastructure that services about 100 million users a day. So with that, let's go ahead and get started with everyone's favorite pop quiz. So I know it might be early for some of you or late in the day for some, but we're going to start with a quick pop quiz. What does the following Go code print at the end? And I know there's a little bit of a lag between what I'm saying and what I see in the YouTube channel. So feel free to drop the letter of what you think it is in the YouTube chat. I'll give everyone, I don't know, about 10 seconds for an informal poll, and then we will reveal the answer. Cool. So this actually prints empty curly braces. How many people thought that it would print empty curly braces? And this makes sense if you actually read and understand the Go specification, but this was actually, we thought it was going to print out the first item there, error key with the value of oops. And the reason for this is that error is an interface in Go. And whenever an interface is marshaled in JSON, it marshals to its underlying type. The underlying type for error string, which is what errors.new and format.errorf generate, is a private type called error string that has no exported fields. And when a type in Go or struct has no exported fields, it encodes in JSON to the empty object. We found this unintuitive. It caused a production outage. And it caused us to not have observability into another outage where we couldn't quite figure out what was failing. We were getting an error back, and then the response body was just the empty string because of a very similar pattern to what you see here. This is a little bit of a simplification. So this is one of the first gotchas that we experienced using Go, and something that we've actually kind of written a little linter for using some grep and some regex to detect. Another area where we had a few challenges were particularly around internationalization. Now, I recognize that not all projects need internationalization. You might be targeting a particular audience that speaks a particular language, but in our case, COVID is unilaterally affecting every country. So we needed our server to be able to support multiple languages. So our user interfaces, as well as some APIs, are internationalized. You sometimes hear this called I-18N, which is I and then 18 letters and then N, which is internationalization. In short, that means that our UI is translated into many different languages. There are RFCs defined by a number of consortiums that talk about internationalization and how browsers and how the web in general handles internationalization. For example, RFC 2616 defines this thing, a header called accept language. It defines the header and the canonical formats for those headers. In your browser, when you set your preferred language, you may not know this, every request that you make, every button that you click, every website that you visit, your browser is sending that header along with a request. So if you were to translate that to a curl command, your browser is always running curl-h accept-language : and then the canonical value for the language that you set. Now, if you're using a modern browser like Chrome or Firefox, you can actually set multiple languages. So the accept language header isn't a single value. It's actually a ordered list in the preference that you want to receive languages back. So for example, if you speak French, you may pick French as your primary language, but then you may pick German or English as your secondary language. And then the website gets that information and it decides, do I want to serve this in French if I have a French translation? Otherwise, I'll fall back to German because that's my next best translation, given the user's preference. All of this happens completely like out of the user's control. All you do is set your preference in your browser. On the code side of things, you then have to read that header and determine which language to serve the request or the response in. So this is kind of what this code might look like. Again, this is a little bit of a simplification, one, to fit on a slide, and two, because we're really trying to zoom in on specific things here, of an HTTP middleware that would parse that header and set a translator on the request context and then call the next chain in the HTTP handling request. So there's a few things that I want to point out here. The first is that the parse accept language function, as defined by the core language package, verifies that the inbound string, which came from the accept language header, is a valid RFC 2616 format. Match, again, which is built into the language matcher, panics if you give it an unknown language. So some of you may have already spotted the challenge here, which is that header is user-supplied information that verifies that the language matches a particular format, but then the matcher itself panics if the language is unknown. So that header is user-controlled data, which means we can't trust it. It specifically means that a user could craft a request with something that matched the RFC 2616 format that would then cause Match to panic because it was not actually a legitimate language. Let's take a look at a more concrete example. If we zoom out and we focus on just the lines here that are still in color, if we pass in a language tag of EN-Z, this is a valid language tag according to RFC 2616. It will pass all regular expressions in validation. However, that is not actually a valid language. EN-US is, EN-BR is, but EN-ZZ is not a valid language tag. So when you give that to matcher.match, it panics. So if we zoom in again, we already know that the header is a user-controlled piece of data. I could run a curl command and set this header. I could set this value to anything. It's untrusted data coming from the user. So what this means is that without very careful handling, including a recover statement, an attacker can cause a denial of service attack on your system by passing in an accept language header that passes the RFC 2616 validation, but is not an actual language header. As you can imagine, the Explosion Notifications project is a target for attackers. We did have this happen, which is how we identified the issue. We were able to quickly mitigate it, but we found this behavior incredibly surprising. There's currently an ongoing investigation on the Go programming language about the best way to fix this in the actual language package itself, as well as evangelizing this particular edge case as a thing that can happen. If you're using any of the internationalization tools in Go today, I would strongly recommend that you either guard against this code path with a recover statement or verify that you're not vulnerable to this particular attack by doing something like an allow list of languages instead of using the parse language match function. So moving on to the next thing that we encountered, the database SQL functionality works really well for small applications. But what we found is that in our particular architecture, it had a number of shortcomings. First, it's really difficult to observe. We saw earlier a talk about like open census and open telemetry. It's actually very challenging to inject that handler and observability code into the database SQL package itself. There are, open census wrappers and a number of other things you can do, but at the end of the day, you end up having to write a custom driver to interface with MySQL or Postgres, even though there's great ones out there, just so you can inject your own observability hooks. The second thing that is somewhat unique to our architecture, because we run on Google Cloud Run, is when Google Cloud Run kills your container, it first scales the CPU to 0, and then there's a garbage collection job where later it actually goes and deletes the container instance itself. Now, that garbage collection interval is proprietary. I can't discuss how long it is, but it's long enough that another request could come in and cause that CPU to scale back up to 1, at which point you were throttled and then you came back online. So it's the equivalent of you taking a Docker container, taking away all of its resources, waiting a few seconds, and then giving it its resources back. The Go language itself doesn't behave well under these circumstances, as particularly anything related to time. And a number of things, including the database SQL package, leverage basically a for loop that results in a race condition in the case that CPU is throttled to 0. And it looks a little bit like this. I've, again, kind of oversimplified to fit on the slide and to highlight the issue. But here you can see we have this for loop where we're going and we're doing some work and we're waiting for the work to stop. And then in the actual work itself, we eventually close some channel which propagates through. You could also do this with context or something else. But the idea here is that after some period of time, we want to cancel. In the case of the database SQL package, this is actually a health check that makes an outbound connection. The problem is whenever this process is in the background and has no CPU, none of this runs, but time continues to click along. So anytime you're dealing with time and CPU throttling, this pattern doesn't work anymore. And CPU throttling to 0 is a very common pattern in serverless frameworks, whether that's Google Cloud Run or Lambda or Fargate. It's very common to scale the CPU to 0. So this is a shortcoming that we identified in the database SQL package, and we're working with the Go team to try to identify ways in which we can make this better given a CPU scale to 0. The next thing that we encountered is something that's not unique to this project. In fact, the community has talked about this many times. Consider the following code. You can think of this as another pop quiz if you'd like. I'll give everyone a little bit of time to respond in the chat. What does this code do if the API key is invalid? So we have this, valid API key call, which I haven't defined, but assume it works. What happens if the API key is invalid? What does this middleware do in that case? Feel free to drop your answers in the chat, and I'll give everyone a few seconds because I know there's a little bit of lag. So there's actually 3 correct answers here. The best answer is E as an elephant, it depends. But the key here is that there's no return statement after the http.error call. What that means is that you return a 403 unauthorized response to the client, but then that code path continues execution. It means we call database.lookup session and any other code that exists in this function body. So depending on the expectations of the code that occurs after this, you may panic with something like a null pointer exception because you expected the API key to exist, or worst case, you have returned a successful response with a 403 status code, which is very confusing to end users and very difficult to debug when you're looking at your logs to try to reproduce this issue. Another area that caused an outage for us was the HTTP default client and HTTP default transport. These are global variables defined by Go. Because they're global variables, they also share state and can easily be overridden by other packages. Any package that you import, always be secure in your software supply chain, can easily modify this default client and default transport using an init function. Furthermore, the HTTP default client itself has no default timeout. This means that when you make a request to a server, if that server acknowledges the request but does not return a response, you've occupied an entire IO thread just waiting for that response. This can lead to a denial of service attack or just really poor performance. Speaking of HTTP, another area which is a little bit of folklore in the Go community is rendering JSON or HTML into a response writer. So if you're building a RESTful service or any type of web API with Go, you're going to be rendering some JSON or HTML back to the client. And in the Go documentation and in blogs on Medium and whatnot, you'll see this pattern. Again, simplifying a little bit for slides, but this general pattern. For JSON, you'll call JSON.newEncoder with W, which is the response writer. You'll encode I, which is the inbound interface, which is like a structure. And if that fails, return an error. And then for HTML, you'll do the same thing, but you'll use like templates.execute template instead. Now, this actually has a problem. If I, which is the interface that we are marshaling, is sufficiently large, we could begin writing a successful response to W and then fail. Maybe there's a cycle in our JSON encoding, or maybe our template execution fails. If that happens, you have already sent a partial response to the client. You can no longer change the status code because HTTP requires that that's the first thing that you send. before you send any body. And you can no longer change the structure because you've already sent partially valid JSON. This is a twofold problem. First, you can't do anything with this error. There's nothing that you can do anymore. Calling http.error isn't actually going to do anything. Second, your clients are going to get really broken JSON. It may be broken up in the middle of a key or the middle of a value, or it may be not valid JSON at all. And that can cause downstream problems for your consumers. So what you have to do instead, in what I would call production ready solution, is to render your template or your JSON into a byte slice or a bytes buffer, and then render that bytes buffer into the actual response render itself. However, if you just allocate a bytes.buffer each time you call render template or to HTML or to JSON, you'll end up with a ton of allocations. And if your QPS exceed Go's garbage collections interval, you can actually, you can run out of memory because the GC won't clean up the old buffers if you have a lot of traffic. So what you really want to do for a production scenario is use a renderer with some type of pool. In this case, I'm using like a sync.buffer pool to reuse this allocation of a bytes.buffer. So here we're minimizing our allocations and we're using the shared buffer pool in order to minimize our memory usage as well as our allocations while also maximizing the UX and the return structures here. There is still an edge case here that you can see in the comment in the bottom where if for some reason writing to W fails, typically this is like the pipe was closed by the client. There's nothing that we can do. We've already sent the response header, so there's nothing that we can do to recover here. So we may just log an error or fire some type of metric that we could alert on later. This gets us as close to production ready as I'm aware of using the buffered HTTP renderers while minimizing allocations. The next area that really bit us was structured logging. So there are a number of popular structured logging libraries for Go, and most of them don't work well with one another. They don't share any common interfaces. If you're working on a big enough project, you have transitive dependencies, which means you have dependencies or dependencies to dependencies that have standardized on a different logging library. Getting those logging libraries to work and play nicely together is often impossible. We've written 3, what I'll call logging adapters, that act as a translation layer between these different logging libraries. Because one of our transitive dependencies decided to use Logros, but our project happens to use Zap. These translators are very computationally expensive. They're doing a bunch of string allocation and parsing. We've done our best to make them efficient, but the lack of structured logging in Go is really a problem, and it's a big source of our CPU utilization. Jumping back over, let's have another pop quiz, just in case you're a little bit tired. What does the following Go code print when it's done? I'll give you a few seconds, again, since there's a delay. Feel free to post your answer A, B, C, D, E in the chat, and I will let you know what the answer is. So the answer in this case is actually CCC. And I'm not the first person to uncover this. It prints CCC because Go uses a copy of the value instead of the value itself in a range clause. It's pretty easy to see in this simplification, but in the actual code that we were working with, this happened with multiple layers of indirection and was very difficult to track down. Worse, it only happened sometimes because it was guarded with a conditional, but it's very easy to make this mistake. So what you have to do here is you either have to copy the value, so do value : equals value inside the for loop, or you have to use your original list needs to be pointers instead of the actual values themselves. Another area where we got bit, where Go is behaving as intended, but we made the wrong assumption, is with non-deterministic select statements. So let's take a use case like the following. If my system is stopped, do nothing. Otherwise, wait for a new worker or new work for up to 5 seconds. And if no work arrives after 5 seconds, return a timeout error. It seems pretty straightforward and easy to do. For example, you may do something like this. You may say, okay, well, I'm going to sit in a for loop and I'm going to select. If I'm done, I'll just return. If I get work from the worker channel, then I'll do the work. And then otherwise, after 5 seconds, I'll return a timeout error. But can anyone spot the bugs, plural, in this code? There are 2. I'll give you a few seconds to post in the chat. So the first one is that we have to check done channel and only done channel before entering the main select. The reason here is that, again, going back to CPU throttling, if our CPU has been throttled for an extended time, it's possible that multiple conditions in that select statement are true. For example, more than 5 seconds could have passed and the done channel has been closed. In that case, by Go specification, who wins is undefined. We could enter either of those case statements. So to avoid that situation, we first check done channel in and of itself in isolation before entering the main select clause. This will ensure that we prioritize checking if the work has been stopped before we actually enter the main select. But this only solves half of the problem. The better way to do this is to actually bring that select inline into every case that you care about. So for example, if the done channel is closed and we get work at the same time, the order of operations of who wins is undefined by Go specification. We always want to prioritize cancellation before doing work. So anytime we get work, we have to check and make sure we haven't also been closed, and then we can continue moving along. The same is true for the timeout though. If we time out, but are also done, we don't want to return a timeout error. We just want to return nothing. However, if we're not done, we want to return the timeout error. So this is an example of how non-deterministic select bit us. Primarily during graceful shutdown, we try to do like draining connections, and we kept getting some instances where we would gracefully terminate an instance and then still get a bunch of errors. And it was largely because of code that looked similar to this, but because we weren't handling the case that 2 cases could both be true at the same time and that the one that wins is undetermined, we got into some situations that were very, very difficult to debug. So with that, I'm going to stop because I throw a bunch of information at you, some of it very, very technical, and I want to make sure there's lots of times for questions. If you have questions, please post them in the chat on YouTube or in the Slack. And if you have questions that you don't feel comfortable asking in the group, feel free to ping me on Twitter. I'm at Seth Vargo. You can shoot me a DM. My DMs are open. You can also reach me at sethvargo@google.com. Thank you all so much for your time, and I'll hand it back over to our organizers.
No problem. Hello, hello. Hello?
I can hear you.
All right, and I can hear you. I feel like, sorry, I might have had a little bit of audio glitch there. Awesome. Thank you so much for that. And looks like we got a question. We got some questions already. We got a question come through the wire. So again, Seth, thank you for that. So first question we have, I have noticed most of the gotchas are triggered by CPU throttling in a cloud environment. Are they only specific to cloud environments, the gotchas that you run into?
Yeah, that's a great question. The gotchas that we run into are easier to encounter in an environment where CPU is not constant. that doesn't mean that it doesn't exist in other situations. It just means that the probability of hitting them is much higher. So you could definitely hit this on premise. You could hit this running your own Kubernetes cluster. It's just a higher probability of hitting it given a situation in which the number of CPUs that's available to the process is fluctuating. I think you're muted, Wilken.
Sorry. What do we have here? It says, wow, didn't know about non-determinism in select statements. Do you know why it is this way?
I don't know why it's that way. I do know that it is like documented specifically in the Go language. Let me find the link real fast. I think I saw that question on the YouTube channel as well. I'll just post a link where you can see the actual like definition. It's in the language specification itself. But it is, again, this is like, I'm not trying to say bad things about Go. We obviously love Go. We picked Go for the language. These are just mistakes that we made that I'm hoping by sharing them, you can avoid making the same ones. And this is one of the ones where like, it's very clearly documented. It's just not really known broadly. And I think the reason that it's confusing is because the sister statement to select is order dependent, right? The actual case statement itself is order dependent. So if you're doing a switch instead of a select, which looks very similar, both structurally and deterministically, switch is order dependent. So if you're switching, like on a type switch, for example, that is evaluated in the order that they're defined, but the select is not. But if you're just glancing at the code, they actually look very similar.
That makes a lot of sense. Awesome. Cool. And I think good. Thanks for sharing that. And I think and you were right, that came in through the YouTube channel. So I got one more question for you. Let's see. Last question I have here is, what sources do you know of common Go production what sources do you know of common Go production gotchas? I see regularly such tidbits from various sources.
I don't know if there's like a single authoritative source of gotchas running Go in production. It's definitely scattered across like random blogs and sessions like this. I do think like we're working with the Go team now to start documenting some of these things, like especially rendering into a buffer before rendering into the response writer. Like that's something that we can definitely solve with documentation and evangelization. Other things are, every programming language has these like, best practices and then production practices. And sometimes they're not the same thing. And over time we learn, there's a lot more people using Go in production today than there were a year ago. And the use cases for running Go in production are also changing. And the scale at which it's being run is also changing. Most people don't run monoliths in Go. It's just not really common. And in our case, like we basically have a monolith. It's a monolithic web application that looks and behaves a whole lot like Rails, but it's written in Go. And as a result, we hit some things that your typical Go application wouldn't hit because it's smaller, because it's more of a microservice or a service-oriented architecture.
Awesome. Sweet. Okay, so I think Seth, I know that you're not in Go for Slack, but is the best place if anyone has any follow-up questions right now, just to post them on the YouTube channel.
Yep, you can post them on the YouTube channel. Yeah. And if you don't feel comfortable posting with your name and stuff, you can always DM me on Twitter. I'm just at Seth Vargo, and I've also posted in the YouTube channel, so you can get my info there.
Cool. Awesome, Seth. Thanks again. Awesome talk. Really appreciate having you on.
Yeah.
Thank you.
Thanks for having me. Bye-bye.
All right. Cool. All right, everyone. Thanks again for joining in, sticking with us, and welcome to all the people joining in. Just a reminder, this event is being recorded and will be available on YouTube as a full live stream and as individual talks. So if it's getting late in the day for you and you feel like you want to jump off, but you're having a hard time peeling yourself away, we got you covered. So we'll be here and the videos will be there when you wake up. So without further ado, I'd like to bring on our next speaker. Just bring him on here. Fred Gernot. I think he should be on shortly.
Hello.
Hello, Fred. How are you today?
Can you hear me?
Yes, I can hear you and I can see you. So
Perfect.
good.
Let me present my screen.
Awesome. Sounds good. So, all right. Fred is a senior software engineer at New York Times. And today he's going to be talking to us about cloud functions and cloud tasks. So, Fred, the show is yours.
Hello. I think I have to quit and rejoin quickly in order to share my screen.
Okay, no problem. Sounds good, Fred. We'll be here waiting. Let's see. All right, cool. I guess good opportunity to take some time for any questions. If anybody has any questions, do a quick spot check between YouTube and Go for Slack. Let's see. Okay. Looks like there's some good follow-up for those, for everyone on YouTube, some good follow-up in the chat, talking about some of the stuff in this the specifications and some good books on the deterministic the determinism of select statements. So definitely try to chime in there. Let's see. Cool. Yeah, it's good. Let's see. I'm keeping a close an eye until Fred comes back. Oh, there he is. All right. Cool.
Okay, can you see me? Can you hear me?
Yes.
Sharing my screen.
Awesome.
Can you see my screen?
Yes, we can see everything. It looks good from here.
Welcome to how to scale GA instances using cloud functions triggered by push notification. What I will talk about today, using Go for GCP cloud functions, queues, and tasks, and the G-Cloud SDK, and using Droid to deploy the function. A little bit about me. My name is Fred Gernot. I work at the New York Times. Mostly my experience is from the front end using JavaScript, and I recently joined a team that worked full stack. Will be a warning. This is my first Go project and my first GCP project. So everything was new and challenging, a little daunting at times, but exciting. The problem we had, we're experiencing periodic random spikes in 500 in an API that was hosted on the Google App Engine. Those outages lasted a few minutes. And after some research, we found out that they matched the push notification that was sent to New York Times users. The auto-scaling was doing its job, but apparently not fast enough to prevent, because we had spikes in traffic, sudden spike in traffic. So the scaling would scale, but didn't keep fast enough to fulfill all the requests. And after a couple of minutes, it would stabilize and all the requests would be fulfilled. So how to fix it? We have two options. Increase the minimum idle instances. That sounded easy, but would probably be costly and not efficient. The second option was to increase the minimum idle instances before each notification and decrease it afterward, after the surge in traffic. And the team that sent the push notification can send us a message when they send a push notification to the user. So that's how we use the cloud function. So we receive like an HTTP trigger that basically launch a cloud function. You can use many languages to write a cloud function. So I quickly thought about using Node. I had a little experience, but the team Amazon is using Go for the main API. And I thought that would be a good occasion to learn Go. And I really like the logo, I must say. And also, like a little note, I'd done a training done by Angelica a few months ago. And I thought that was really fun. We did like use channel to bring ping and pong. And so I decided to give Go a go. So how you trigger a cloud function? You just call its URL, very simple. When you create a cloud function, it comes with boilerplate, says hello world. So every time we get a push notification, I could print hello world, right? So how do you go from like 0 to something? So this is the interface in the GCP UI. When you create a cloud function, you give the name, the type of trigger, and you can add some environment variables that are used by your function. This is where you enter your source code. It's in Go right now. So when I started, I was copying and pasting in the UI, which is not really efficient, right? And I discovered Quick Labs. So they offer like tutorials to basically centered around GCP to learn like how to work with cloud function, how to work with queues, how to work with tasks, setting dashboard. And that was great because everything was brand new to me. And at the time of COVID, I didn't have the resource of like asking coworkers. So I needed a lot of help. So I used that. That was pretty great. And I discovered the cloud SDK through Quick Labs. And sorry. Yeah, so I could use, you can use your favorite IDE to deploy to the CLI. And much easier to like, sorry, I'm not used to like, do conferences. So yeah, let me take a break. So you can yeah deploy through the sorry. Sorry, that's my screen. Okay. Sorry, I need to take a break. Is that okay?
Sure, sure, absolutely.
Okay.
All right. Sorry. Do you need to take a break, Fred? Or
okay? I just lost my train of thought. So yeah.
Okay.
It's a bit easier to like, use the Cloud SDK so I could deploy to the CLI my cloud function. Oh yeah, that's my screen. Okay. Okay, so this is how you you actually manipulate the instances in the GAE. So you basically patch the version and you pass the minimum idle instances and maximum idle instances, where you change the the number of instances that are running in GA. So this is an example of the Go code I used, where you pass those two values that are defined as an environment variable. And this is an example of like using the CLI to deploy a cloud function. So I wish I had seen Valentine's presentation. So it took me a while to basically learn how to deploy a function. So you set the name of the function you want to deploy, the type of triggering you want to use, and you define your environment variable, the YAML file that contains your environment variable. You can also define the runtime, and you can do many things such as switching project, listing the project, your current project, and listing the GAE versions that are active or not. So that's something I find out the hard way, is that there's a limit of the number of versions that you can hold in the GAE. So while I was testing a lot, the number of versions was increasing, and I ran into an issue later on where I hit the number of versions I was getting around. But I'll get back to that later. So what goes up must come down, right? So my first idea was to handle the scale up and scaling down in one function and wait a set amount of time within that function. But when you run a cloud function, there's a time limit of 9 minutes for cloud execution. Makes sense because you don't want to start function that runs forever. But what if you want to wait more than 9 minutes? So here comes queues and tasks. So the scale down is handled by a different function that's triggered by a task. The task is created in the scale up function and put in the queue to be executed at a later time. So this is a link where you can see how to create a task in a cloud function. And you can also define a scheduling time, which was perfect for my case because I wanted to run that function in the future, basically. And you can also limit the number of times that task is retries to trigger the function, which was great because I ran into another issue where I had an error in my scale down function. So the task kept trying to trigger that function, but that function will try. This is how I define the time to scale down. So basically take the time now and add the amount of minutes that I define in my environment variable to when the scale down task would be executed. And this is the final setup. So you got the messaging team that sends us a trigger that launch the scale up function that would scale up the instances. At the same time, it put a task on the queue that will trigger the scale down function at a later time and scale down the instances. So now the importance of dashboard. So I was checking the dashboard we had in GCP and seeing the correct behavior. Every time I was testing the function, I could see the instances going up, certain amount of minutes going by, the instances going down. But when checking the dashboard over a few days, I realized that the function was were working correctly. So we were receiving messaging from push notification. I could see the function being executed, but the instances were not scaling up or down. So the reason for that is that the GAE version was changing every time I was deploying a new code to our API. So that's something Matt mentioned, about managing version, but that's something I found the hard way. I had no idea. Basically, my function were running into a version, but that was not the version that was getting traffic. That was getting real traffic. So the instances were not scaling up. So yeah, the way I solved that problem, I had to find the current version, update my environment YAML with the correct version number, and redeploy that function, which you can imagine is not very efficient. So then I moved to a drone deployment, so I could sync my the GAE version to sync the GAE version with my function. So they would be always in sync. Unfortunately, there's a drone plugin for that. there's a link. I don't know if you guys are, I guess I can share the links afterward if you're interested. So I have 2 steps in drone. So the first step is to prepare the deployment. So in my YAML file, I have a placeholder that's being replaced by the actual version. Here's the command that I use. And the second step in the Droid deployment is to actually deploy the function. And here about the version limit. So when I was testing the Droid deployment, I quickly hit the limit because I was deploying a lot of version. We have like a development environment. So I was like testing the drone deployment. So I was like increase the number of version. But there's a way to like, first I had to like manually delete all those old version. That's time consuming. There's a quick way in drone so we can set the max number of version that's kept in GCP, so you don't have to manually delete them, which is very useful. And that's max version 10. So here's an example of my environment file where you define the project. And here you see commit ID is the placeholder that's going to get replaced by the actual like GAE version. You define the number of instances, the maximum instances up, the instances that go down, and the bracket between the minimum and maximum. The name of the queue and the URL of the scale down function that's going to be executed, and the time from like the scale up to the scale down. And a few numbers now to conclude. It takes about 12 seconds from the time we receive the triggering message until the messaging team actually sends the notification to the user. The cloud function runs in 250 milliseconds, and it takes about 4 seconds for the instances to scale to the full number set in the environment variable. And there's an average of 6-minute lead time between the trigger until we see like peak traffic. So that leaves us a good margin. And thank you. I hope you enjoyed the presentation. That drawing is from my 4-year-old daughter. She's an avid drawer. And I don't know, it reminds me of a gopher. All right. So if you have any questions, I'll be happy to answer them. Sorry about the technical glitch in the middle.
It's all good. No need for apologies. It's a lovely drawing. I see the gopher as soon as you posted it. I was like, oh, so yeah. It's good. Yeah, Fred. First and foremost, thanks for again. Welcome to the community. Really happy to have you on, and I really enjoy hearing stories from new people coming in and their perspectives. So again, thank you for signing up to talk, and it's really good having you. So. Let me take a quick peek at the Slack channels, and I apologize for looking back and forth. I'm going between Slack and YouTube, but let me see if I have any good questions here. I think one question that I see, I don't see questions right exactly. One question that comes to mind now is, after deploying it and having to maintain it, is there something that you would have, and especially now looking at Valentine's talk, is there anything that sort of jumps to mind that you would do differently, or that you want to go back and revisit?
No, I mean, I wish I had seen like all those talks like before, because I didn't know about the SDK. So it took me a lot of like trial and error to get working, and Go was brand new to me. So I was kind of like trying a lot of different things in Go and in GCP at the same time. So like the learning curve was pretty high, but I had some help from like workers and like seeing talks. So but yeah, like I wish I knew then what I know now, basically.
Okay. No, awesome. That's good. And actually, as you start to talk
the journey was really interesting. Learning history and everything.
Awesome. Yeah. One question came in right around, along the lines of what you're discussing now. It's like, did you need to refer to many online references, or were the main documentation pages enough?
No, I had to use like Quick Labs was like super helpful because I mean the online documentation is like very comprehensive, but at the same time it's like extremely big and very like technical. So sometimes like what I like about Quick Lab is like some kind of like it's very structured. So we're gonna do this, and here are the steps to do it, so that really you can really discover things and understand what you're doing, as opposed to just like copying and paste code from online and running it and see if that works or not.
Awesome. So I went ahead and share the link for you on the room, the Chrome plugins. So and threaded talk Go Stock. So it's for you to stick around and check out for Stock if you have any questions. So, all right. Fred, again, thank you. And I'm going to go ahead and start preparing for the next one.
Thank you.
So, all right. So I'm going to go ahead and invite Stephen.
Hey, how's it going?
Hey, Steve, how's it going? Pretty good. Thanks. How you doing today?
It's a day as crazy as any live streaming day, right?
Yes. All right, so I think we're good. Let's see. So I just get all right. So welcome. Thank you for doing this. We're happy to have you here. So before kicking things off, just a quick round introduction. So everyone, this is Steve Hoffman. He's a senior backend engineer at Contact. And today he's going to be talking to us about his journey from Python to Go on GCP. So without further ado, Steve, floor is yours.
Cool. Yeah, so let me just share my screen here. And then I will watch, everybody can look at my calendar. Boop. And so I think is everybody seeing this? Yep. Okay, cool. So I'm assuming that it's just good to go. And so I'm just going to go with it. So yeah, so today I want to talk about what we're doing here at Khan Academy, because I think it's pretty interesting. So first, what is Khan Academy? Khan Academy is a nonprofit, if you haven't heard of it, that our mission is to provide a free world-class education to anyone everywhere. And we do that through a lot of different ways. We have a lot of people who are really interested in trying to make the world a better place. And this is one of the ways that we feel like we can do that, by actually helping other people to get a high quality education no matter where they are in the world. And as part of that mission, one of the things that I'm really proud about is that we learned a long time ago that having a diverse workforce helps us to be able to actually to do better, to think better, and to be more clear in our to make better solutions that fit people better. And as a result of that, I really love it. And I love the fact that my coworkers are some of the kindest people that I've ever had the fortune to work with. And so I wanted to do this talk as a kind of as a love letter to basically say how much I love working for Khan Academy and some of the great stuff that we're doing. So the stuff that I'm going to present today is not my work, but is the work of some of my coworkers. And I wanted to basically just say how cool they were in having figured this out. So again, Khan Academy, we're trying to fulfill that mission, and how we end up implementing it is actually, I think, an interesting story. So I actually have been working there for a year and a half, and I worked at a lot of other places before that. And so I'm a senior engineer at Khan Academy. Mostly I do back-end stuff here, but I've done front-end at other places and DevOps at other places. So I already went ahead and talked about this, but so I do love what we do together. And I wanted to tell you about how we started out. Originally, Khan Academy was got in on GCP App Engine when it was still in beta. And we built a Python 2 monolith on top of that. And I think that that was actually a really excellent decision. And it ended up being a gamble that really paid off for us. We still love App Engine, and we plan to continue to do so. One of the things that was great about it was that when the pandemic hit and we had just a huge, normally we have an exponential curve of growth over our timeline, but we just had a giant wall, a surge of people who were using Khan Academy, and it really didn't have any problems in production as a result of that. There were a few little things that needed to be tweaked here and there, but I think what's pretty amazing is that because we run on GCP and because we don't let ourselves get entangled in other things that don't provide value, and we just offload that to GCP App Engine, we are able to actually focus our organization more on providing value to the people who we really want to serve. The thing that we do need to change is that we actually have found that Python 2, first of all, it's end of life. Secondly, we've grown as an organization engineering-wise, and our code has also grown in complexity, and it's becoming difficult for us to maintain the level of, as our monolith has grown and grown and grown. So we're actually going to use multiple Go services, and we are splitting things up into 27 different Go services. These aren't necessarily incredibly microservices, but they do break things up. And we're using GraphQL in between them. And I want to talk about how that has been a tremendous boon to us. So when we picked that Python 2, we ended up picking Go, and it actually, we found that our individual Go services are much faster. There's a really rich ecosystem, so we're not building everything from scratch. We find it very simple and productive. The other thing that I really want to say about Go is that everybody talks about how fast it is, but it's maintaining somebody else's code is a real pleasure in Golang, which I don't know is necessarily the case for other languages. I've maintained a lot of legacy systems in a lot of different languages, and I really love different programming languages. They're fun to geek out about and to be able to play with. But the problem is that I love writing my own code in those languages. I don't necessarily like maintaining somebody else's code in those languages. Especially as an application grows over time and teams come and go, you have a language where you have multiple different paradigms and shifts. Sometimes it's actually pretty complicated to try to get into the mindset of whatever this piece versus that piece look like. Where when I'm maintaining someone's Go code, it looks pretty much just like my Go code. And I think that that's a real testament to the simplicity of the language itself and the elegance with which it was designed. So when we were picking which platform we should run on, we again chose App Engine, and we helped to avoid undifferentiated heavy lifting. It scaled great, like I said, during COVID-19. The other thing I want to say is that it is so reliable to be on GCP with App Engine. We have an all volunteer PagerDuty. It's opt-in. I've been at places where it seems like, oh, we're cloud scale, but people are waking up in the middle of the night all of the time just to keep turning some crank to keep the system running and intervening to keep it reliable. And that's not our experience at all. We've had less than one after hours PagerDuty a month. And a lot of those were false alarms. But, we thought, we could really cut those down. But, it's good to stay in practice. And I feel like that is so different than the industry standard that it's worth trumpeting, because I think a lot of people end up picking other solutions, and they end up actually having a lot of sleepless nights as a result, where I sleep incredibly soundly knowing that everything's on App Engine. So thank you. The other choice that we had to pick was whether we should stick with a monolith or whether we should switch to services. And it's a difficult choice because we already were changing things a lot by switching from some other things. So we chose to switch things to services because really it actually helped us in a human scaling way to be able to have some sort of encapsulation that this was a team's domain and that they could actually be able to really go deep with that. We also found that having independent deployability had a number of advantages to speeding up our overall organization's productivity. We also found that it gave us pretty granular cost tracking that was aligned to specific values. So, for instance, a particular team might have 3 or 4 services that they were involved in, but we could tell that a particular business value that we were trying to provide, we could see how expensive that was versus how much value it was providing for those students or teachers or districts. And we could actually tell, oh, you know what? This service right here is actually, it's really very expensive and it's not really adding a lot of value. Maybe we should rethink this. Or this particular service is really cheap to operate and it is actually super useful. And so we should invest in that and grow that. And that just kind of falls out from using services, where when you have a monolith, it's possible with profiling to get that same sort of information, but it doesn't just magically fall out in the same way. And so we found that to actually be pretty useful. The communication between different services is also an open question that we had to decide. And so we had great success on our front end with using React with GraphQL. And we decided that since App Engine did not support HTTP2 or gRPC yet, feel free to put that in our Christmas wish list. The thing that we really liked about GraphQL was it provided a ubiquitous language across both JavaScript and Go, and that we could actually write things that were schema driven and code generated. And that helped us to not have to deal with a lot of contract testing that we thought would be brittle. It helped us to be able to have our backend engineers being able to really be able to understand with very little impedance exactly what the front end engineers wanted to deliver. And it's helped us as an organization in a number of other ways that I'm going to go into. So we also had to decide, okay, so if we're going to divide into services, how should we divide those things up? And so this is like a brief summary of some of the 27 services. And we decided that our basic architecture, we're fronted by Fastly. They're awesome, by the way. We use Apollo's GraphQL gateway to provide federated GraphQL queries and mutations across our different services. And then our different services are broken up, lined up across business value or domain. And that's worked out pretty well for us. So one of the things that we've learned, some things that we've learned as we've transitioned, is that we made a simple test-driven development command line app to help engineers who were new to Go. And we basically did it the way that Khan Academy works, where we have all the tests were already written and people tried to just make the test pass. And there were comments with individual code snippets or hints that as you got further along, usually the first hint is just a basic, hey, maybe think about this, looking at this documentation. And then the last hint is always like, here's the complete solution, so you can just paste it in if you need to. And that was actually a pretty gentle way to introduce people to it. It's also a testament to Go that it had a pretty straightforward syntax. After that, we invited people to use Learn Go with Tess. And we had the whole organization trained by Arden Labs, and Bill Kennedy was awesome. And then we've actually developed an internal cookbook so that whenever there was a problem that we've encountered, especially if you see it more than once, we tried to actually make, here's how to solve a common problem. Like if you're like a recipe, for instance, if this is the kind of Python that you're trying to port, here is how we have done it in Go in the past, and use that as a reference. We've also have an onboarding repository that we've been contributing to and helping other people in other meetups be able to look with. So having trained our engineers, we wanted to actually then focus on how to safely transition applications. And we didn't want to do a big bang rewrite. We wanted to be able to gradually do things in a very safe and incremental way. And one of the ways that we chose to do that was to use a form of traffic shadowing, where requests will actually go to both Python and to Go. And we will compare them, but we'll only use the response from Python until we feel confident that Go is ready. And we can always switch. And when we switch, we can always switch back. This technique, I think, was first popular with GitHub's scientists. And there's been other libraries and other frameworks where this has been implemented. But as far as I'm aware, this is the first time that I think an organization has used GraphQL for this kind of side-by-side testing, and specifically GraphQL Federation. So I wanted to talk about it because I think it's actually kind of cool, and it's been so seamless and so wonderful that I think it's worth other organizations looking at it as well. So the way that we start out is we have all the code is written in the Python monolith, and then we develop in a Go service things that will actually fulfill the same contract, the same that's defined in GraphQL. Then we switch things to Python being primary, where Go is secondary. And the responses from Go are compared to Python, but the end user only sees the Python responses. And when we feel like we're ready, we can switch to have Go be primary. And so now the end user is seeing the Go served responses, but Python's still secondary, and we're still comparing those. And then we can transition to having it just be run by Go only. So when you're inside of the monolith, this is kind of how a request would look like. It goes from the front end through the GraphQL gateway, and then it would go to Python. We then develop the Go service, and we then have Python be primary, but we have Go be secondary. We then have Go primary, and Python is now secondary until we transition it to be Go only, and we delete the Python code. So now it's code time. So the thing is that when you have a GraphQL schema, it looks a lot like this. And so this is an example field that we actually really had to port. And what would happen is we started out, this is the GraphQL schema before when it was just in the Python. And we started to actually build things in Go. Now, the problem is that when you have a federated schema, you can't have two things that define the same field exactly. Otherwise, that's an error for federation. So we have a directive called migrate that basically will hide this field from the full schema, and only the gateway will really know that it even exists, so that other services, they don't need to know that there's two things that are implementing this. It's just a gateway implementation detail. And we set the state there as manual, so that it would have to be that somebody would manually have to opt in to getting this from the Go service. And then we switch that to be side by side, which indicates that now we want to actually have requests going to Python, but that that they should actually be served and compared from both of those. When you look at the side-by-side differences, you might see that there's a slight difference. Maybe the time zone is wrong or some other kind of thing. This one I just kind of pretend I made it a bug on purpose so that it would actually be more interesting to look at. But then you can also get a number of different reports by different services and different file paths, and how those different operations might have had over, millions of users or millions of requests that happened in the last, hour or something like that. And you can get a full, more detailed report that talks about that. And some of those changes might actually, you look at them and you're like, oh, that thing is actually not sorted properly because it was an unsorted list in both of those. And so, yeah, okay, I see why that is the case. So I guess we'll sort both of them temporarily, and then we'll try it again. And we're confident, okay, now we can go back. And then maybe later we can switch it off of being sorted for better performance because we never really cared that it was sorted, so. We also see all these different metrics that they're watching. This is just one. We have like lots of different SRE dashboards that show us different fine-grained details so that we can find like, oh, there's occasional errors or other sorts of things that are happening. So when we're all done and we think, okay, this is actually good to go, we're set, we can change that in the schema so that it's actually fully migrated. And what this will do is now Go is serving and actually Python is going to be ignored. So once that's actually, we're fully secure with that, we can actually delete the Python code and delete the actual migration directive and just have it be served from Go. So again, this is, you start out in a monolith, you develop in a Go service, then you actually have Python be primary where Go is secondary, and then you have Go primary and Python is secondary until you transition to Go only. And this is a really safe way to get through this with large scale migrations, building it in the air while millions of users are using it. So, but this begs the question, this is great for queries, but for mutations, how do you deal with that? If you're altering persistent data, side-by testing is not really such a great idea. Like if the mutation is that we want to increase some student's skill by 1, well, if you do that twice, you'll end up with, oh, the skill increased by 2. So we need a safe and gradual traffic shift. And ideally, that would be internal traffic first. So if you look at a traditional deployment, the main super popular way that started out was blue-green deployments. And, or I think Netflix calls them red-black because it's logo compatible. But what you do is you release a new version alongside the old version, and then you switch. So that all those requests, they start out going with the first one. And this is an example of like a Grafana dashboard that would show that traffic. And you just flip a switch, and now everybody's getting it from the other one. So side-by-side traffic, the traffic looks more like this. You release a new version alongside the old version, but the incoming traffic is mirrored to the new version and doesn't impact the response. You're just comparing them and looking at errors and performance and all that kind of stuff. In a canary, you're able to release a new version to a subset of all users and then proceed to a full rollout. So you start out with only a few users, and we start that out using our handy different GraphQL canary. And you may, if you're a fan of ornithology, you may have, know of the different species of canaries, such as the great North American GraphQL canary, seen here with its hexagonal plumage. And so the thing with what we use with those canaries is that we have a selective release of features to a random subset of requests for testing purposes. And we gradually increase traffic from 0 to 100%. This can be either manually done slowly, or we can do it fully automated if we feel confident that just monitoring the metrics that we have tells the whole story. So if you have more than 0%, that means that all internal users will get the canary treatment. So they'll get the responses from that canary, where we might have most of our actual users still getting the results from the original Python monolith. So this is a nice way where what we'll do is we'll change the schema so that when we have the Python code, we'll have the beginning of the Go code, and we'll have a migration there when the state will be canary. And we pick a color because canaries are colorful, and we like to be able to have only a few experiments going on at the same time, so that you don't get sort of a mix of canary colors that are sort of obscuring the data. At the same time, we don't want to necessarily it uses an exponentially larger amount of memory to have to try to have a whole lot of different canaries going on for the same fields. And so we want to try to limit that as much as possible. And so then what happens next is we will switch it so that after we have either manually or automated switched all the way from 0 to 100% of the traffic is being handled by the Go code, we will then actually be able to delete the Python code and delete the migration directive from the Go code. So the upshot of this is that engineers are happy and productive using Go code, where before they had a lot more trouble trying to figure out what was happening in the Python code. Our efficiency has gone up quite a bit, and our costs are bending down. What's next for us is that we have 65% of our production traffic is served by Go. We are open source by default. So if there's a solution that we have that is useful to other people that we can make independent enough from our own bespoke stuff, we would go ahead and open source it. And we're sharing our onboarding process to try to be able to help other people to be able to take advantage of the good fortune that we've had in investing in both Go and in GCP and in GraphQL. So if you're interested, feel free to reach out. We are indeed hiring, and I am open to any questions.
All right, Steve, thank you so much. Great presentation. I really love the imagery and the flow. So thanks for that. And also really happy to see that you get back to the community, open source, and sort of putting out the your playbook, if you will, on how to do this. So pretty awesome stuff. Let me take a quick peek at the chats to see what we have any questions come through the wire. Let's see. And I hope that you can hear me okay. Apparently my sound was pretty choppy.
You're good now. Yeah.
Yeah, I'm good. All right, good. All right, so let's see. Nothing, I have nothing here on the Slack channel, nothing coming through. And then I'll take a quick peek at on YouTube. And just a reminder, we're threading everything in Go for Slack, folks. So if you're there and you had a question, didn't get a chance to type it in just yet, just drop it in, and whenever Steve gets a chance, he'll be able to follow up with it. All right. Okay, Steve, I think we're good right now. So again, I really thank you for joining us. Okay.
Hey, thanks very much. Appreciate it.
All right. Awesome. You are. Thank you. All right. So we are coming up to the end here. We have one more speaker. Again, thank you to everyone for joining in. For all those that are burning the midnight oil, thank you. And for those that are looking to get some rest or just kind of step away for a bit, these talks will be recorded. So are being recorded, shall I say? So they will be available for you later on. All right. So just gonna get our next speaker up. Misha, you should be able to hear me and see me.
Yep, I am here.
Hey.
Hi, I'm Misha
Awesome.
Avrik. Can you hear me?
Yes,
Okay,
yes, we can
great.
hear you.
Hi.
So,
Hi.
awesome.
I actually pre-recorded my talk just to avoid any technical difficulties. So I will try to share my video right now. Hopefully that will work. And I'll be here in person to answer any questions while I'm presenting out of a little bubble here.
Okay, sounds good. Thank you. So, just so you're a software engineer in the New York Times. You're going to be talking about cloud functions in Go.
Yes. Yes.
Yes. Awesome. Awesome. All right. I'll put myself on mute. So Misha, you just want to make sure you're sharing your audio. I see the video playing, but we don't hear any audio.
Sorry about that. Let me try again.
No apologies necessary. It's all good.
Hi, I'm Misha Avrek. I'm a software engineer at the New York Times, and today I'm going to walk through implementing and deploying a cloud function in the Go programming language. Here's our use case. We have two cloud buckets, bucket A and bucket B, and we have a compute engine instance where a cron job runs, let's say, once per day, and it copies a file from bucket A to bucket B. Simple enough. Here is a slightly different version of the same use case, which is the one that I'm going to talk about today, which is basically performing the same task with a cloud function. So in this case, I will implement an event listener cloud function that will listen for when file is created in bucket A, and when that file is created, it will automatically copy it to bucket B. First of all, quick recap. I know this came up in other talks today. What is a cloud function? So cloud functions are, as I already mentioned, single-purpose functions attached to events emitted from your cloud infrastructure. So like in this case, we'll be listening for a specific event, the file being created in the bucket, and then when that event is emitted, the function will get triggered. Similarly, event-based functions can listen for other events, such as files being changed or deleted, or similarly, database records being created, changed, or deleted, such as Firebase database records. And also, there is another type of cloud functions, which are the HTTP triggered function, where you basically trigger a function by calling its URL. And also, you can talk about cloud functions as a platform. So in a second, I will walk through the code for this function. The Go code that exists for the cloud function that I will be deploying is really the only thing that I need to worry about to perform this particular task. I don't need to worry about setting up the server or any of the other execution environment related tasks. I just write my code and deploy it. So with that in mind, let's quickly, let's walk through the function code. So here's my function. Like I said, it's waiting for this file to be created in bucket A. So this is the event that will trigger this function's execution. The first piece of code that I have here is a struct that describes that event. So the event ID, which is a unique ID for the event that will be emitted, the file name, the bucket name, the content type, and the time that was created, that the file was created. These are the parameters that I'll be using in my code, but there are a lot more parameters that you can potentially use that are emitted with an event and that you can use in your code at this link. Second, you need to define your environment. The environment, as we will see shortly, is defined when the cloud function is deployed. In order to bring your environment variables into your function's code, you need to define a struct to contain those environment variables. In my case, I will just use one variable, the name of the destination bucket, so that you can easily change it in case you need to copy a file, not to bucket B, but somewhere else. But potentially you can use other other environment variables, such as authentication parameters and many others.
And finally, I have a struct to define the parameters for my destination file, which you will see in a second. So here is the main function of the main part of my cloud function, the so-called entry point function. So this is the function that gets executed when that event, the file creation event, is emitted in the cloud. This function takes two parameters. It takes the execution context for the cloud function and the event, which is pre-filled by the Google Cloud Platform. And this event is of the type that I described above, this struct. All right, and it returns an error if there is an error, the main function. So first we process our environment configuration, return an error if we fail, check if there is a destination, if the destination bucket was defined, because we need to know where the file will be copied to. Connect to the bucket and create the client. Again, error if failed. Read the metadata from context. So this is useful for logging. Some of the metadata that's contained in the execution context, such as the event ID or the event type, that I will mention. The event type is basically what happens with the file. In this case, we're just listening for the file being created, but there are a couple other event types also useful to log as part of your function. And then the bucket name, the file name, and the time the file was created. These are all good to have in your logs. So once all of this is done, we can read our file from the source bucket. Let's take a look at how that's implemented. Here's our read function. It takes the same context as a parameter, just passed in from the main function. The client that was created in the main storage, Google Cloud Storage client that was created in the main function, we can reuse it here. Then the bucket name and the file name. And it returns a pointer to an array of bytes or an error if there is an error. So first we open a handle on the bucket and we open a new reader, an IO reader on that handle. Again, check for errors, return errors if we have to. Defer closing the reader until the function returns. And we read from the file. We read the contents of the file into our bytes array. Again, check for error and return the pointer if everything is okay. So that's our read function. Back to the main function, check for errors. Failed to read, one of the possible errors here. If everything's okay, we go on to copy the file to destination. So this is where we use the destination file struct. Also fairly simple, just the name of the file, the name of the destination bucket, and the content type. You want to make sure that when you write the file to the destination, it's created with the same content type as your source file, since you're just copying the file. And we store the file. Again, here's the function. It takes also the execution context. The same client can be reused. And the destination file struct, which contains all the parameters I just described. And finally, the file contents that you will be writing, which is a pointer to the bytes array. Check that we actually have something to write to the destination bucket. If the file contents are empty, then there's nothing to write. Return an error, and again open bucket handle. So I'll open the bucket handle. Set up an object with the file name to write to. Open a new writer, IO writer on that object, set the content type, and write the file, check for errors. If we can't write, return an error. And finally, close the IO writer and again, check for errors. If everything's okay, we do not return an error. And that is basically it. That is the body of our function, and we are ready to execute our use case and test it and deploy it. Before we deploy the function, I want to quickly talk about two things or two questions. First of all, as we saw in the original use case, we were not using a cloud function. I proposed using a cloud function to improve this use case. So quickly talk about why. And second, why use Go for this particular task. My apologies for my early spring allergies here. So let's to answer those questions, let's go back to our first use case, bucket A to bucket B, a compute engine instance and the night cron job. One alternative to that first use case that would work, that would not involve a cloud function, would be to set up a Cloud Run container that would essentially do the same thing. It would be triggered by a cloud scheduler, and it would run gsutil copy on a file from one place to the other. So sort of the same thing, smaller footprint than a full-fledged compute engine instance, but this would work. In this case, you have to execute, or in both of these cases, you obviously have to execute your task whether or not that file that you're copying exists. So you would be saving on the cost of your entire operation if you only executed this task only when that file actually exists. So one of the benefits of using cloud function is to save basically to save on the costs of your setup. And second, a cloud function is just easier to maintain than either a full compute engine instance or even a full Cloud Run container, because all you have to do is write and deploy your code. So let us actually try and deploy it and see what happens. So before you deploy Cloud Function, you need to do two things. One is you need to make sure that you either have your Go mod with all the dependencies specified in the same directory as your Cloud Function, or you need to have vendoring activated. You need to have your vendor folder with all of the dependency code in the same directory as the Cloud Function. And also, when you're deploying for the first time, you need to make sure that you have the Google Cloud Functions API and the Cloud Build APIs enabled. It will, if you use the gcloud CLI command to deploy, it will be using Cloud Build under the covers. So both of these need to be enabled. So let us try and actually run the deploy. So here is my command. So quickly, while it's running, I'll mention a couple of parameters here that are useful to keep in mind. It will take a couple of minutes, sometimes longer. The trigger resource is the bucket that your function will listen to for the object creation event. So bucket A. The trigger event is the event that it's listening for. So Google Storage Object Finalize is when file creation is completed, either by way of a new file being created or in a version bucket when a new version of a file is created. But like I mentioned, a function can listen for other events as well. It is useful to explicitly specify your region. If you don't, your cloud function will go to the default region for your project, but that way it is possible to end up with multiple versions of the same function in different regions. So it's good to specify it explicitly. And then finally, this is how you specify the environment variables, destination bucket, you remember from the code. If you have more than one, you can do a comma-separated list of key value pairs for the environment variables. And of course, runtime Go. And we let it execute. So our function has deployed. You get some output explaining what got deployed and where. It's successfully deployed, it's active. Let us now go into the actual Google Cloud Functions platform and see what we have there. So here it is, the console, and here's our function. It has been deployed, the trigger, the runtime, the memory allocated, everything is specified here. Let's take a look at the function and the logs. So here's the most recent deploy of the function, and it got deployed. Now let's actually test it against an actual storage event. So let's go into storage. I already have my bucket A and bucket B defined, created here, and I tested earlier, so let's delete this file. Same here. So here we have our buckets, both empty, bucket A and bucket B. So now we can test, just upload a random file to bucket A. Files, here's a file. Here it is in bucket A. And here it is in bucket B. So our function worked. Let's just verify that by going back into the logs. And here we are. So it executed, function executed, function execution started. It logged the event. Remember that logging statement that I mentioned with the metadata and so on. Here it is, when the function was successfully executed, the bucket name, the file name, and so on. So everything's okay. So now we have our cloud function deployed and successfully executed. So we've got an improvement on our initial use case. We have a cloud function that's listening for a file that's been created and copies into another destination. Which brings me to the second question that I wanted to talk about: why use Go? So obviously, this is a pretty simple use case. You're just copying a file from one place to another. You can use GSUtil for that purpose, and it will probably work just fine. What you get with Go is a few things, the advantages of using Go. One is the logging that you've seen. Go has pretty advanced logging capabilities built into it, which we have used and that you would have to set up explicitly with something like a shell script. The other thing is, if this were just a slightly more complex case, if you weren't just copying a file from one place to the other, but let's say, or from one Google bucket to another, but let's say if you wanted to copy a file from a Google bucket to an Amazon, to an AWS S3 bucket, or if you wanted to write your file as a blob type object into a database, or if you wanted to parse your file based on some database schema and write the contents of the file into a database. Go has APIs defined for all of these situations. You can write to an S3 bucket with the right permissions if you have the permissions set up. Same for the databases. So just by changing the code, you can the Go code, you can fairly easily accomplish those tasks if you had to change your use case to accommodate those scenarios. And finally, some pointers on good coding practices for cloud functions written in Go. With cloud functions in general, you need to keep in mind the possibility of cold starts. So if your function is not used for a while, it goes cold. It basically loses its execution environment and takes a few seconds to start up again. The cold restart time is actually shorter with Go than with other runtime environments. So that's another reason to use Go, but that is something to be aware of. It adds latency to your application if you get a cold start. Always make sure that your function returns. You may remember in my code, I checked in the main function that all the returns were there. If it doesn't return, it can kill your entire execution environment, such as if you use an OS exit, you basically lose your execution environment and you get a cold start. Specifically for HTTP triggered functions, make sure that you set your headers before anything can get written back to the client. Incorrectly set headers can actually lead to security issues. So you want to make sure that headers are set even before anything gets returned, including errors that go back to the client. Delete all temporary files. Any and all temporary files that your cloud function might create can actually get written into memory, so it counts against your memory allocation. And if you get a memory overflow, your function will crash and you will get a cold start. This is all I have for today. Thank you for listening, and please let me know if you have any questions.
All right, awesome, Misha. Thank you so much. I think the first question that came through the wire is, sorry, I'm just gonna bring it up on my phone here on the YouTube, was how are you handling the camera view, on your recording?
Oh,
Is that a dedicated app?
I used the program called Loom. This was, I should say this was my first time like pre-recording a talk like this. So yeah, Loom, it's an app, worked okay, I guess. I apologize about not pre-downloading the Zoom plugin, but yeah, that's what I used.
And well, it looked great, so no apologies necessary. I think that's why the question came up. It looked really good, so thanks for that. And I thought the talk was great. I've smartened up for this one. I got looking at a few screens here to see if I have any questions come through. So hopefully the audio sounds good and not too much jitter. But I'm not seeing any new questions come through on Slack or YouTube. But once again, we threaded your talk in the Go GCP meetup channel. So I encourage folks who may have questions to add them there, and Misha can come through maybe later on and respond to them. And take it from there. Cool.
Thank you for having me.
Yes. Thank you for speaking. It's really happy to have you. So thank you. And I guess if you be happy, you're more than welcome to stick around as we close out the event. So again, great stuff today, everyone. I really want to, take a minute to thank all our speakers and all our attendees for joining and sticking with us today. I mean, these events would really just be me and Angelica chatting without y'all. So thank you so much for joining in. We already started prepping for our next event. So we like to do these these mini conferences, as we call them, every 2 months. So I think, we had already had something slated for March, but really in honor of Women's History Month this month, we're already working on our next event that is slated for May, Glorious Go Gals. So if you're interested in speaking, please reach out to myself or Angelica. Love to have you. And if you want to help in any way, definitely just reach out. You can hit us up on Slack, Twitter, and I posted our emails on the YouTube channels. So thank you. And I look forward to seeing everyone else at the next event. And, feel free to check out the videos once they go live sometime later today or tomorrow. All right, everyone. Thank you. Many blessings. Really appreciate having you on.